All right. What's up, everybody? Welcome to Grasshopper 101. I think we are now live on YouTube. This is our first time hosting a video, so we're getting used to hosting and streaming and all that kind of stuff, but looks like we are live and ready to go. What's up, Guillaume? How are you doing?
I'm good. Good afternoon to you.
Good afternoon. So we were just checking out some of the comments and asking where people's from. It's super awesome to see. There's a lot of people from Nigeria. I saw Pakistan, India, the US, Portugal, Russia. Man, it's everywhere. I mean, that's super exciting because this was part of the reason we did this was to try and make it as accessible for as many people as possible around the world. Hence why we ended up on YouTube. So thanks everyone for joining. So just before we get started, there's a few things we'll go over. But yeah, we'll just kick things off. And welcome to ATN's Grasshopper Masterclass and today's module of Grasshopper 101. We're super excited to get this started. Like we said, it's our first course and we've had a great response. We had over 1,200 people sign up. Hence why we're here on YouTube, because we needed to host it on something that was a little more scalable. So thank you so much for everyone that is joining. As I said, if you are joined and you haven't added your comment yet, we'd love to know where you guys are tuning in from. We're super curious, like how far the ATN, how far this course has traveled. And we also really want to kind of understand where people are tuning in from so we can get a vibe of what's going on in the architecture world in your part of the world.
And hoping it's not too late for some of you.
Yeah, we tried to do this. The reason why we picked this time is like, so we cover the US, most of Europe. We got a lot of Africa and all the way to kind of India. I think if anyone's in India, it's a little bit later. We got South Africa's on a similar time. Seeing Lebanon, Vancouver, Portugal. That's awesome. That's super awesome. So maybe to jump into things, we're not going to hang around too much chatting. We'll start with a little bit of an introduction to myself and Guillaume, just so you kind of get an idea of our backgrounds and how we've kind of been using computational design ourselves over the last few years. So for those of you who are unfamiliar with myself, my name's Oliver Thomas. I'm a British architect. I studied in the UK and became a qualified architect. I'm one of the co-founders of ARCHI-TECH Network, along with Guillaume and Faisal. And I'm also the current design technology manager at BIG here in London. So yeah, I've kind of, my background, I've been a designer, I've been a facade consultant, and I'm now a kind of specialist. And I've always been interested in technology, and I've always been kind of gravitated towards computational design and Grasshopper. And at university, I was definitely kind of really interested in computation and learning things like Grasshopper. But unfortunately, there wasn't really a lot of resources during my master's to do it and to learn it. So I was kind of having to learn a lot myself. Obviously, there was YouTube at that time, but it wasn't as popular in terms of videos and stuff you can download and watch. But it was one of these things that, like, with Grasshopper, you can get stuck for ages without learning. So, I went to some of the courses and found these 101s, like, they were useful, but I found that no one really explained exactly how to do these, the reasoning behind why you're doing this stuff and these components. So I started to learn a lot more when I was in practice. I worked as a designer and I started to use it to like create facades and design things. I then worked at Front, where I got to use computational design and Grasshopper to fabricate and build facades. We worked on a lot of products like the Zaha Morpheus Hotel and things like that. And now I'm using it a lot. Obviously, at BIG, I kind of am an in-house consultant where I'm helping teams with computational design, BIM, augmented reality, and virtual reality. So I've always been interested in the intersection of architecture and technology, hence why we started the ARCHI-TECH network. That's a little bit of my background. Guillaume, do you want to give the crowd a bit of a background to yourself?
Yeah, I'll do a quick one. Thanks, Ali. So I'm a French architect, or I was trained in France. I actually did what's called a dual degree architecture engineering in Lyon, and I saw there is a maybe at least one French person in the audience. So
Yeah, do we
hi.
have any?
And yeah, so I actually started my career on the engineering side as a structural engineer. And from my engineering education, I kind of knew a little bit of programming, and then it became really useful once I started as an engineer. Just simply Visual Basic programming to deal with pretty much just numbers at this point, and trying to optimize some workflows. Um, but in the back of my head, I wanted to go back to architecture eventually, and I had the opportunity to work at Big for about 7 years total. Started at the bottom as a junior designer and went up to being a project lead there. And through this experience, I started to like, you know, I started with the scripting side, but then Grasshopper came on, and it's just easier to share with people that don't know programming, obviously, and it's just more convenient for like day-to-day applications. It just goes so much faster. So it was integrated in my workflow as I was designing options, etc., and proposing, and people starting to like peek at my screen and be interested. So started to do some schools internally in the office too, to kind of share that knowledge. And then when Ollie came on board, I guess we kind of took it to the next level, did an actual true what was it, 3 half days, kind of solid
Yeah,
training for everyone, so that we can really go through the basics, because an hour or so here and there is not enough. So I feel like
yeah.
we need to dive in.
And that's
Um,
kind of where this Grasshopper course came from. This is very much based on what we teach in house at Big, and we've obviously tweaked it a bit for ATN, but we spent some time really thinking about what are the foundations of Grasshopper and how can we teach that to completely new people to the world of Grasshopper. So
yeah, my life took me now to Arizona, so I'm not that big anymore. But I think this thing that we started together, Oliver, and with Faisal, is set to last. So that's what ties us from Arizona to London to Nigeria
yeah.
at this point.
We do have an AI Faisal in the background. So a few before we jump into a few like housekeeping things. So like we want everyone to ask questions. Obviously, you're not on the video with us, but you are welcome to ask questions. You can just simply ask questions in the YouTube chat, comment in the chats, and we'll at certain points we'll pause and ask questions. We do also have a Discord channel, which you can see in the link below in the description to this video. And Faisal is there listening to your questions, and he'll be fielding some questions. And so if you have a question a long time, at any point, post it, either comment below or on our Discord. I have a rule, and we've always said this whenever we teach it. There are no stupid questions. Ask any questions. Like, this event is live, yes, but it won't be hosted on YouTube. So once we take it down, it'll be taken down. There are no stupid questions. If you're thinking this question, probably half the other people in the audience are also thinking that question. So don't hesitate. If the only thing is, if you do comment in YouTube, we obviously can see who you are. If it's in Discord, it will be a little bit more anonymous. The Discord is also not just for this event. That is something that we're going to curate as we move forward. So you'll be part of the ARCHI-TECH network in Discord, where you can, post a question and the community and us can answer it. And you'll see what kind of things are coming up in the future. So I think that's it. There's a little bit of an introduction. There's already a question that I think I might answer from someone in the comments. Do you have to learn code to use Grasshopper? The answer to that is no, not really. Traditional code. And in fact, in this presentation, we'll address just that. So yeah, I think that's it. Let's, without further ado, I know you guys have been waiting for this, so let's just jump into it. Do you think, Guillaume, is there anything else we need to add?
Let's go for it.
I'm looking for my list as I'm taking these things off. All right, let's jump on. Okay, I'm going to share my screen. Guillaume and I are going to disappear for a little bit whilst I go through this presentation, and then we'll reappear a little bit later. All right, guys. So the first part of this course is really just going to be an introduction to computational design and Grasshopper itself. Okay, so the first thing we're going to talk about is what is Grasshopper. If you look up the definition or you Google it, it basically says Grasshopper is an algorithmic modeling plugin for Rhino that uses visual programming language. Obviously, that makes it extremely clear what it is. Not. So we're going to try and explain that in a slightly clearer way, I hope. So what is Grasshopper? What is algorithmic modeling plugin? And what is visual programming? So, in a very, very basic sense, Grasshopper is a plugin for Rhino that allows us to get under the hood of Rhino's functionality and create basic algorithms and scripts and processes using the Grasshopper components and interface. The typical kind of workflow for Grasshopper is you are, usually referencing something in the Rhino world. You're referencing a piece of geometry, a massing or something. You bring it into the Grasshopper canvas. You execute a process of these kind of step-by-step components and things like that, and then you output something back into your Rhino workspace. Now, this is what I would say is the basic workflow for Grasshopper, but honestly, it could be anything. You could be importing information from Grasshopper from an Excel file and then using that to build geometry in Rhino. You could go from Rhino to Grasshopper into Revit. So that, it really is a blank canvas in terms of how you use it. But this is your typical workflow. And this is what we'll be doing a fair bit today. We'll be creating things in Rhino, reference them into Grasshopper, and vice versa. The second question is, and one of the comments already was, do we need to know coding? And the answer is no, because when you say coding, you think of this, right? Lines and lines of code, or like in the movies, is someone in a hoodie trying to hack into someone else's computer or something like that. Architects do use coding, and as specialists, we do use a bit of coding and things like that. But for the most part, we use what's called visual coding. So as architects, we are very visual people. We spend all our time making 3D objects in a virtual world. And so it kind of makes sense that our version of coding is done visually. So instead of lines and lines of code, you have these little components that are laid on what's called a canvas and joined together through wires. And through this, you can create a kind of sequence of components and functions that collectively can make some really intricate, interesting processes. So if we look at these two examples, on the left-hand side, we have a code example, and on the right-hand side, we have a visual scripting example. They both do exactly the same thing, right? So this is just using a kind of a basic script to kind of move an object, and you have to insert various different requirements to make that function work. The same thing happens in Grasshopper, right? This is the component and the function we're trying to use. These are the inputs you need to kind of add in order to make it work. And so the reason why this is kind of way more usable for us as architects is, one, you can really kind of see and also play around with things in a real-time basis. So when you're in Grasshopper, your typical Grasshopper script can look a lot like this, right? So on the left-hand side, or at the beginning of your script, you have all these parameters and sliders that are controlling various things. In the middle, you have the functionality, the kind of whatever it is that you're doing, or the sequence of components and functions. And at the end, you have some kind of output that you would bake back into the Rhino space. You can kind of also read what's going on here, and you can also see in the background as you're developing your script, you can also see the thing that is producing the geometry that you're actually creating. in this script, you can kind of read that it's making a grid. It's obviously putting a sphere on each one of the intersections of the grid. And then there is some kind of setup where there's a point somewhere in the middle here, and the closer the sphere gets to the point, the smaller the sphere is. And so this is your kind of a very, very basic but typical script where you have your inputs, you have your process, and then some kind of output. And so typically the way that Grasshopper works, and a good place to start with Grasshopper, is to think of it as a kind of a linear process. You may know where you want to get, and we're simply using the computer to get there a bit quicker. So I always say with Grasshopper, a good place to start is to think about how you would actually manually model this thing and try and just record that in Grasshopper. Even with a linear process, scripts can get very, very complicated. But it's still quite a powerful thing. But Grasshopper is capable of taking that one step further, where you can actually start to have a conversation with your computer. So you're inputting things and you're creating some kind of scripts. The computer is actually spitting things back at you, so it can spit 100 different options of a tower massing, and then you can pick 5 that it then goes in and iterates again. And this is where that kind of generative process comes from. So for the most of today, and from beginner to intermediate, you're typically working with a linear design process or a linear computational process. Another way to look at the term computational design and Grasshopper is to think of our friend Mr. Dell here, who many of us sit all day in front of our little friend, whether he's called Dell or Alienware or Mr. Mac or whatever they're called. We don't usually think about what our little colleague here is good at, right? So, hello, this is Dell, and Dell's very good at these things, right? He's very good at maths. He's incredibly good at processing large amounts of data, communicating really quickly. He's obviously got a great memory if he's got enough space to fit it in, and all these kind of things that we know computers are really good at is otherwise known as computation, right? This is the kind of computational power of a computer, and these are the things that a computer is really good at. So when we talk about computational design and the term I'm a computational designer and things like that, it's essentially just referring to you designing with the use of computers, which may use a mathematical approach, or you may be using it to generate geometries, objects, information, and architecture itself, right? So as computational designers, you're really just utilizing the computational power of your computer to design things, right? And this is where that term, for me, computational design is the kind of umbrella term for that. And underneath it, you will also hear in this space of parametric design, right? Automation, generative design, even BIM, AI, and scripting, right? All of these kind of terms are subcategories of computational design. We're utilizing the computational power of our computer to design things. But even even within the industry, like people debate whether it should be called parametric design or computational design. And honestly, it doesn't matter. You can call it whatever you want to call it. I think there is a kind of interesting argument that parametric design, in theory, all architecture is parametric in that everything, the site itself is a parameter, the brief is a parameter, but it's kind of was coined in the early days of Grasshopper, and it's almost become like a bit of a style. But doesn't really matter whether you call it parametric design, computational design. I lean more towards the computational design headline, but whatever you call it, whether parametrics, computational design, scripting. One thing I really, really want to get across, and one thing that's as a computational designer, we're always kind of trying to change the stigma that comes with tools like Grasshopper, is that parametric computational design, it doesn't mean only super complex expressive geometry, right? I think and this project here is not at all a swipe at Zaha. I think this is a project that I worked on as a facade specialist, and I was kind of the computational design has given us the ability to create these amazing forms and these amazing shapes and designs, and also given us the ability to actually go and build them. And without these tools, buildings like this would not be possible. And that's an amazing thing that happened within our industry. And over the last few years, we've been using Grasshopper and computational design to create this amazing architecture. But really, that's been the tip of the iceberg, to be honest. And we've always been kind of working our way. Even now, when you say we're going to use Grasshopper, people think your building is or your design is going to turn into this, super complicated, expressive geometry. When we look at this other kind of, if we go to the complete other end of the spectrum, we have this tower here, which is in New York. This is Raphael Vinoli's super tower in New York. And this is a very, very simple building in terms of geometry, right? It's the plan is a square, the windows are square. You can see it almost looks like it's the same floor to floor all the way up the tower. It's not one that you would look at and think, they probably scripted that, right? And to be honest, I don't know if they did or they didn't use any kind of computational tools in this project. But it is incredibly scriptable. It's incredibly logical, right? You can see the base of the building is very definable as a rectangle. You could very quickly model this and test out various different sizes for those windows. And even though it's an incredibly simple building, you could use, or a simple building from a geometry perspective, you could use computational design to iterate through this and detail it very quickly. The building on the right-hand side, you would need Grasshopper and computational tools to quickly model it. But the left-hand side, you could use computation to model it to a really high degree, really quickly. And then what's interesting is you could then take that script and iterate through other things. So maybe they would have had more time if they wanted to, as the designers of this, to play around with different size openings for the window. Maybe there's a gradient from large to small. Maybe they could shift the floor plates. So, whilst this is not like a very geometrically complex building, and it doesn't, you look at it and you don't think, oh, they probably use Grasshopper to design this. This is a very scriptable building. And then, of course, as Bigsters, we have to mention where we kind of fit, into this. And I think Big is a good example of somewhere in the middle of expressive yet kind of pure geometry. So this is our Vancouver Tower. What's interesting about this is you can clearly see we're kind of utilizing computation on two parts. One, to create interesting function-driven forms. So in this case, if you were to think about the surface that is actually creating the Vancouver Tower, that is a quite a complex double curved surface, right? But then the question is, how do you actually turn that surface and build it using conventional building methodologies? And you get this kind of interesting pixelated effect where each kind of unit is protruding from the original surface. So it's something that is very much ingrained in our design process and in many design processes around the world. So here you can see again our towers. This is a Vancouver Tower in Vancouver, Canada, and also the TELUS Sky Tower that's also in Canada. We're clearly using computation as part of the design process at Big. The Serpentine Pavilion is also a great example of how do you build quite a complex shape out of this simple extruded boxes. The Cocoa Towers, how can you add a simple twist into your building to maximize views as you go up the building? But it's not just about design. Like I said, like you can use computation to also turn these ideas into built form. Like what if the contractor needs that each one of these balconies actually extends in increments of 200 millimeters or 300 or whatever that numbers are? We can use computation to rationalize and optimize our design. Again, the Serpentine, I think, is a great example. Like, how do you make this really interesting? If you think about the underlying surface of this, it's a complex double curved surface. But how do we build it out of sheet planar materials and construct it in a way that's simple and achievable based on the budget and timeline that we have. Also, how can you make sure that each box overlaps with including tolerances and things like that, so that when it does rain, because this was based in London, it's not, a completely porous structure, right? There's also a little bit of shame. The 103 course, I will add, will cover the actual scripting of the Serpentine Pavilion. And then, for example, the Miami Towers, how do you add a twist, but at the same time make sure the structure doesn't kind of go over certain parameters? How do you make sure you maximize those views without the structure protruding through the facade, or cantilevering or something like that, based on the structural engineer's parameters, for example? So it's something that I have and we've been using in the office as part of our design process. It's a design tool, right? We use Grasshopper as a way to iterate through different designs, explore different designs. So it's very much ingrained in our design. We can use it also to analyze our designs as we're designing them. So we could take a massing. This is a very quick, fun snapshot of like a quick daylight analysis of the Serpentine, so that maybe we could work out where we could put solar panels if we were going to put solar panels on or something like that. So we can use computation to analyze our designs as we design them. We can also use it for optimization. Like, what if we tried to optimize the pavilion so that this diagram here kind of highlights which boxes are of similar length. So then we can kind of look at this and think, is there a way we can optimize this so it's a little more efficient to fabricate them without losing the intended form? And finally, we can take this all the way through to actual fabrication. Like, if we've been using Grasshopper and computation to actually create all these objects, how can we use that to continue that process into the actual act of fabrication? I think one of the main things, and one of the reasons that we want to host this, and we've been hosting it for free live here on YouTube, is we want to avoid people doing what's called manumetrics. So this is something we've nicknamed manumetrics. And as you can see from the icon of someone kind of exhausted at their desk, this is when people try to create computationally looking designs without using computation. And for example, this brick wall, someone is rotating each block individually 1,000 times, right? Whenever we see people doing this, or if you're doing this, come join the Discord and ask us some clues on how you could do it, or go onto our YouTube and look up videos, because I think throughout my career, from university all the way into practice, I have come across this, and I've always go to people, just stop, let's have a look at this, and let's take a little script for it. So at all costs, we want to avoid manumetrics in the industry. Hence why we wanted to create this course and at least attempt to give you guys a basics of Grasshopper. So the other thing is that, when we talk about computation, what computational tools are we actually using? If those of you who are new to ARCHI-TECH Network, you can follow us on Instagram, where we've been asking various established and emerging firms about the tools and technologies they actually use on projects. And what's interesting is, even though we're only 17 projects in, you can see computation is one of the most used categories that we have. So I think the number is at 94%, which means there's only maybe one or two, I think, of people that haven't used computational tools on the project that they submitted. And out of those computational tools, Grasshopper has been by far the most common computational tool we have. It also is worth noting that Rhino is consistently the most used modeling platform so far that in our questions. And so most firms, these, I would say, are a typical array of computational tools that people use. So we have Grasshopper, which obviously I've given a bit of introduction. Rhino Inside, which is a little bit of a cheat, because Rhino Inside is just Grasshopper inside of other programs, and it's most commonly used inside of Revit. So now you can use Rhino and Grasshopper to reference and create real Revit geometry. Dynamo is, of course, Revit's own version. It's their own Grasshopper, which is specifically for Revit. And of course, there are various different programming languages that's used in the AEC industry, but by far, I would say Python is probably the most useful to use. But of course, today we're only interested in Grasshopper because I think that is the one that I recommend for people to learn and to enter the world of computational design. And whenever you're learning Grasshopper, people always ask me, like, what's the best way to learn Grasshopper? How do I learn Grasshopper? I think I've distilled it into these 4 elements, which the aim of this course is to address most of these areas as we go along. So the first thing is actually one that people don't necessarily think of straight away, and that is thinking computationally or computational thinking. So, whenever if Guillaume and I were going to create a script for someone, or we were just talking between us, we would kind of usually start with a piece of paper and sketch out the idea that we're trying to create or the problem we're trying to solve, and trying to think a little bit about the steps that we need to go through in order to create that thing or that process. And there are lots of books on thinking computationally that come from more traditional coding backgrounds, like Silicon Valley and development coding. It's one thing I really recommend to spend some time looking into, because I think it is a slightly different way of thinking than you do as a traditional architect or designer. And I really think it complements a lot of what you need as an architect. So the first thing is just starting to think computationally. How do you break down this problem into a step-by-step phases or step-by-step problems? The second one is components, right? There is a big part of just learning what components Grasshopper is. And this is one where it's, I could sit, if I was to sit here and talk to you through all the components, we'd be here for maybe a day and a half, and you guys would probably be extremely bored at that point. So a big part of components is just over experience. We'll obviously be covering a lot of new ones today. But a good place to start is, if you're already familiar with Rhino, just think of the commands that you use. So then you'll be able to rethink and step through that process of how you actually model it manually. I'm always learning new components myself. It was only like last week I was helping out an intern, and they were using a component that I'd totally forgotten about, or there was another one which I'd actually never used. And so you're always learning about new components and things like that. The other 2 elements, which are really what we'll cover in these 2 days, is lists, which is kind of the way data is structured behind the scenes in the form of lists and data trees. And I always say to someone, once you've understood and mastered lists and data trees, that is when you become a Grasshopper Zen, a Grasshopper wizard, so to speak. So that is some of the things that we will be going through today and tomorrow. Today we'll be learning about more lists. Tomorrow will be data trees. So that's a little introduction of computational design. Now, I don't know if there's any questions. I'll stop here if there's any questions about computational design. And let me just have a look through the comments as we go along.
I think there was a question about how much of Rhino do you need to know. I mean,